today is all about how to draw and transform a certain graph. If they've given you f of x, they want you to sketch that, and from that also sketch minus of f of x, f of bracket minus x, and bracket on both. So minus on both. Alright, so girls, let's treat this like we usually do. Let's make it equal to y, and from here, as usual, what's the y-intercept?
0.
Yeah, 0, yeah? Now for the x-intercept, I'm going to factorize it as usual and find out what the x values are. And can you tell me straight away?
0 and 2.
Yeah, 0 and 2. So let's plot those points over here. So it has to go through 0, it has to go through 2, and it's concave up. So this is my graph. If this is my graph of f of x, girls, let's just have a look at it algebraically. What happens to this graph over here if I put a minus in front? Girls, if I put a minus in front of the whole equation, because that's what minus f of x means, minus f of x means put a minus around the whole original equation. So if I do that, alright, so I'm just going to do my algebra work here. Let's factorize for x. So I'm going to take negative x out. And what's in here though? Minus 2. Yep. And from here, as usual, x is equal to 0, x is equal to 2. Right? So it goes through the same points, but on our x squared, we have a minus. So it's the same graph, but upside down. So instead of having to show you algebraically to show you what the graph should look like, here's your note, girls, in the x-axis. So you're reflecting in the x-axis. Okay? Let's just have a look at it algebraically and see what happens if I now substitute minus x into the original equation here. So if I put it in bracket, yeah, you with me so far?
Yeah.
It's like what we used to do when we tested if it's odd or even function. What's the first one? That, but what's my second one? Yeah, so there is a difference. So let's see what happens if I factorize x out. Girls, what are my x values now? 0 and minus 2. So I'm going to draw the original graph so I can show you the comparison. Let's just say this was my original graph, all right, in dotted line. Now, because it goes to 0 and minus 2, it means it goes to 0 and minus 2. And is it concave up or down? Up. So this is my graph when you have minus x in it. So what's the note here? In the y-axis. Very good. Okay? If there's a minus in front of f, as well as minus inside the bracket, girls, what you do is, it doesn't matter if you do, let's do that first. What was my answer for this? The blue line, right? Yeah? And then if you put a minus in front of that, all you need to do with the blue graph is now reflect it about the x-axis or the bottom. So the answer is just basically this. It's a reflection of f of x in the x and y-axis. Okay? Girls, it doesn't matter if you reflect it in the y-axis first, then the x-axis, okay, as long as you reflect it in both. So keeping these notes in mind, now let's actually apply it straight away here. Girls, are we listening? So girls, this is my original f of x. If I want to now sketch, minus f of x, what did I say? Is a reflection of the whole graph in the x-axis. So flip it upside down. That's what it means. So girls, flip it upside down. Okay? See, if that's, once again, if that's f of x, now I want, where's my blue pen? If I now want f of bracket minus x, I'm going to reflect the sidewards. So what does that mean? Now, this is important. Instead of going through minus 4, that means on this side it's going to go through? Yeah, instead of going through 1, it will go through? Minus 1. So let's do this. Oh, yeah, it should be a bit more up here. Yeah, good enough?
Yeah.
All right, so minus in both the bracket and outside. That means all I need to do is just take one of these and reflect it. If I take the blue one, I now have to reflect this now what? To get minus, so I've done minus bracket x. If I need to put minus in front of it, what do I need to do with the blue line? So flip it upside down. It's going to go through once again minus 1, and then on this side it's going to go through. Yeah, does that make sense? All I've done was just flip that upside down to get to the last one. All right? In order to draw a hyperbola, you first need to make that equal to 0 to get the asymptote. So x cannot be 1, because if you sub in 1 in here, 1 minus 1 is 0, and you can't have 1 over 0. Yeah? So this is your first of all asymptote. Okay? And because it's a plus 1, the graph is going to look like this. Okay? And if I want, and now I need to know that point. How do I find out what that y-intercept is? How do I find the y-intercept? Sub x equals 0. And if I sub x equals 0, what do I get? That's right. Okay. Girls, the reason why this is important, from here, as usual, girls, let's sketch minus f of x. So we have to flip it upside down, but to be exact, instead of going through minus 1, it will now go through 1. That's why that point is important. And that means I'm going to now have this, and this is going to look like this. So in purple is that. Okay? Secondly, but in the exam, girls, you've got to draw that separately. You can't leave your answer like that. You have to rub off the original graph. All right? Now, with minus x, you're flipping the original graph sidewards. The reason why this now asymptote value is important is instead of 1 being the asymptote, it is now minus 1 that's the asymptote. Because when you're doing f of minus x, remember you're reflecting it sidewards on the y-axis. So, how's that graph going to look like? It also has to go through what?
Minus 1.
Yeah? Can you see that? Yep. Lastly, if I now want to draw on top of this, minus on top of what I've just drawn, what do I have to do with this graph now? Flip it upside down. So instead of this, it's going to look like this. Oh, never touch the asymptote. And instead of this, it's going to go through 1. All right? So this is my graph of minus x. The reason why I want to show you this example is, can you see my final graph I just drawn? Looks awfully similar to the original graph, but they're not the same. Yeah, but the asymptote has changed. Yeah? Instead of 1 being the asymptote, it's minus 1.